we are almost done now. Look at question 16. It's right here. And it's AB is parallel to CD. And also AB, look at it, it's a diameter of the circle. So because we have these parallel lines, we can use maybe corresponding, like for example, C4 is equal to A2 here because they are corresponding angles. And even if you do this, you're seeing a Z here. This angle will be equal to that angle. You know, you can use it whenever you feel like it. The parallel lines, if ever the question asks you to use it. Now, EG is a tangent, which brings theorem 7 to life right there. And then we also have C2. C2 was given to be 54 and B2 is 35 degrees. These were given. You know, I just quickly changed ABC to B2. I hope you're noticing that one on your diagram too. Do the same. Right, so after we have this, we can see as well that there is a diameter. It means we're going to use angles in a semicircle quite a lot. And then even here, you can see how these will be 90 and that will be 90. It's subtended by the diameter, so we can keep that in mind as well. Well, let's go to the questions themselves. So 16.1. What do we need there? From what we are seeing, we have to calculate E1, and that is that angle over there. That angle is not a problem because it's an angle between a tangent and a chord. It's the one that you used theorem 7 to find, that one, most of the times. So you can see there is a tangent and it's chord EB. So you hold both ends of that chord. You just go with it until it reaches the circumference. If it doesn't touch the circumference, it doesn't count. So these two angles right here are definitely equal because of the tan-chord theorem. But again, at A1 there is nothing, so you also have to perhaps find what's equal to A1. And again, look, EB, this one, is also equal to this one. Oh, we could have come this side already, isn't it? So we using this same tan-chord theorem, this same chord, EB, can go into A1, or we can come to this one. So I'm going to use the shortcut here, which just says E1 is going to be equal to C2, which is given to be 54 degrees. Why don't I do that? Otherwise, the first thing I saw was it's equal to this one. So you could have also said that these two are in the same segment. So that's how this one will become equal to that one. So keep that in mind. We can use it at one point as well. Well, that's E1 for us. Let's find C1, where C1 is. And it's right here. So if you look at C1, you are convinced how we are going to use the diameter here. So we shouldn't have problems with that. This diameter AB is subtending C1 and C2. So the correct statement will become C1 plus C2 is equal to 90 degrees. These are angles in a semicircle. They are subtended by the diameter. Those are angles in a semicircle. So this one, C2 was given to be 54 degrees. So C1 will not be a problem to solve. So let's quickly subtract that 54 from 90. It should be child's play. And I'm sure you got your 36 degrees over there. So C1 is equal to 36 degrees. So that when we add these two, we will get our 90 degrees as we were hoping. So we will eventually get our 90 degrees. Okay, that is C1. Very simple. We were calculating. We were asked to calculate that one. Let's go to the next one. It's C3. You need to find it first before you do anything. Oh, and there it is. Here is C3. So if you're not seeing what I'm saying, I'm going to help you by highlighting it now. These ones are parallel lines, people. And let me just finish off my Z. So of course, if this is 35 degrees, this right here should also be 35 degrees. And I'm sure you're shouting the reason right now. So let's write it down first. C3 is equal to B2. I'm going to put it like this. And these ones as Z. It's alternating angles. And we are saying they are alternating because AB is parallel to CD. Like that. So our C3 can easily be seen as 35 degrees right there. Okay. Good. Hope you're following. So here is 16.4 as well. Right. Let's find AED. AED is this whole triangle, this whole angle right here. That's the one we want to find. Right? To find that one, it's very clear we are going to have to use the fact that the angles in a semicircle will be 90, but 90 degrees is this whole thing. This is 90. Those are angles in a semicircle. So it means we have to find E2 first, so we can find what this angle is. So I may have to find E2, so I can subtract it from 90, so I can get this one. I think you're following there. And E2 is not a problem. We are running out of color, so you have to follow my fingers. Look at arc BD. BD subtends C3 at the circumference. And the same BD subtends E2 at the circumference. There's this little bow tie here that you're looking at with all four corners touching the circumference. It means this angle will be equal to that angle, and also this angle will be equal to this one. So we want to find E2. It's definitely equal to C3 right there. So I'm going to use that one. So E2 is equal to C3, angles in same segment. So E2 itself, since C3 is equal to 35, even E2 is 35 degrees. Okay, this part, we calculated it to be 35, but this whole thing is 90. Let's write it down. You know, what we want is E3 plus 4, but what we know is that E2 plus E, let me write it as AEB, so we can get to what we want first. E2 plus AED. AED is 3 and 4, okay? Is equal to 90 degrees. These are angles in a semicircle. Like that. So what I'm saying is, if this is 35 degrees, finding AED should not be a problem. Okay, you are done calculating that one, of course. So let us write it down quickly. All right, so it's your 55 degrees. AED then will be equal to 55 degrees. This one. So this angle, this whole thing is 55 degrees, and that is 35. So we may put that one there. So we're almost done, so we just need everything to be there. Now let's go to 16.5 and see how we are going to calculate E3. Well, where E3 is right here. Now we know that E3 plus E4 is 55, but what is E3? So as you can see, it's a polite way of asking you, find E4 first. You know, the sum of these two is 55. You now want E3, so all you need to do is to subtract E4. And it's very simple because E4 from where we are, E4 is equal to B2, which is 35 degrees. Those are angles in same segment. Are you seeing it? E4 and B2, this one. So you can see theorem 4 dominated this question. So if you know that one, you are getting that easily. So this one now is 35 degrees, and the sum of the two, we just calculated it to be 55. So from here, we can easily subtract these two and say, therefore, E3, if you subtract these ones, it should be 20 degrees. It's a therefore. So that is what we get for that one. So as you can see, even this question could easily be done. It was mainly theorem 4 here, a little bit of theorem 7, but mostly theorem 4 and the angles in a semicircle. So thank you very much. That's question 16 for you. Mark it, please.